atoms that represent a specific element will have proton and electron numbers that are constant. But neutrons can differ. Let's look at the atom hydrogen, represented by the letter H. In this notation, the atomic number is down low. In the periodic table, it's up high. But the atomic number is always the number of protons, and you can see with hydrogen, it never changes. We have 1 across the board. The proton's in the nucleus, so there's our 1 proton, there's our 1 proton, and there's our 1 proton. So in all 3 of these images here, we have hydrogen, because what defines hydrogen is the 1 proton, because 1 is its atomic number. If you look on the periodic table, you'll see hydrogen's atomic number is 1. There's the 1 electron that's in its energy level, flying around the nucleus. But what changes, or what can change, in an atom that represents an element is the number of neutrons. And with different numbers of neutrons, we have different isotopes. So take this hydrogen atom. How many neutrons does it have? 0. Well, how about this atom? 1. This atom, 2. So you can see these are all hydrogen atoms, but the difference is the number of neutrons. So these are isotopes of each other. Sometimes isotopes are given different names, but they're all forms of hydrogen in our example. So an isotope will have different masses. What's the mass of this isotope? Well, what has a mass in an atom? Protons and neutrons. Remember, electrons are nearly weightless. 1 proton, 0 neutrons, so the atomic mass is 1 for this atom. What's the atomic mass for this atom? Proton plus neutron, that's 2. The atomic mass is 2 for deuterium, which is an isotope of hydrogen. What's the atomic mass in tritium, which is an isotope of hydrogen? Its atomic mass is 3 because there's 1 proton and 2 neutrons. All the mass of the atom is in the nucleus. Electrons are nearly weightless, so we don't have to worry about them when determining the mass of an isotope. Let's work through this question together. The atomic number of carbon is 6. What does that tell us? There's 6 protons. That defines the atomic number. How many neutrons are in carbon-14? Now, this is an isotope, carbon-14. You'll see the element with the number after a dash. Now, an isotope is named according to its mass. So that's telling us that carbon-14, the atomic mass is 14. So how do we take the mass of an atom? Well, we know from the previous slide that protons plus neutrons equals the mass, the AMU, atomic mass unit. Well, what do we know here? The atomic number of carbon is 6. That means there's 6 what? Protons. Do we know how many neutrons there are? It doesn't tell us. But what does the question tell us? Well, the entire mass of the isotope. Remember, an isotope is named according to its mass. So carbon-14, the mass is 14. So if the question says, how many neutrons are in carbon-14? Well, you just fill in the blank here. 6 plus what is 14? It happens to be 8. So if you're given an isotope question, it would ask you here, how many neutrons are in carbon-14? The answer would be 8. So basically you're subtracting the two numbers they give you to find the number of neutrons.